welcome back to the Baltic Penguin, or Ostsee-Pinguin as my channel is called, because I'm from Germany and Ostsee-Pinguin is German, and most of the stuff I'm doing on this channel will be in German, but I currently started a little series on Brendan's USE-method, which I want to do in English. I have a first video on that, which is a little bit a mess when it comes to my English, and I speak very slowly and have a lot of ams in between, so I recommend it to better run this on 1.5 speed. Maybe that's a good tip for this video as well, but we will see if I'm doing a little bit better today. I have to get used to speaking English a little bit again after not having been speaking English for quite a while. And I also, these are still some of my first videos I'm doing, so I need to get used to this as well. So please apologize if not everything is perfect, but I hope that the content is still interesting for you. So what is the use method? I said it in my last video, and I recommend that you watch this one as well. It mainly is a method where you go through the utilization, the saturation, or possible errors for several system components on Linux systems or on any computer system, but we will be looking on Linux tools to get information on that. I already said that I will not do anything on checking for CPU errors, because it's not I don't know about possibilities to do this on the command line in Linux. Maybe there are some special tools for that I don't know about, but we will concentrate on utilization and saturation. So the last video was on utilization and how we can check for this, and today we will look on saturation. So what if there's anything happening that brings our CPU to its limits. And for this, we want to look on the run queue of the CPU. So there we have a value how many threads are in the, or how many processes are in the run queue, and this number should not be above the number of CPU cores that we have. So before we check for the values for the run queue, we need to know how many CPU cores we have on our system. So today I'm on another system than last time, where I only had one CPU core. So we want to see how this is here, and we can use a tool for this, which is ls CPU, which gives us a lot of information about the CPU, but we want to specifically check how many CPU cores we have. So we just do a little grep with the option M for M1 for only the first match, and we search for CPUs, so with the S in parentheses, and this gives us the number of CPU cores that we have. So another method that we have, if we maybe don't have the ls CPU command, is that we just look in the CPU info file on the proc file system. So we just do a grep M1, and we want to search for cores in this file, in the file proc, CPU info. Yeah, of course, I don't need this pipe symbol here, and I don't want to run proc CPU info, so this would be what I really want to do. And what is this? We only have 4 CPU cores. Well, this is because Intel is using a feature that's called hyper-threading. We can check for this also the CPU info files if it's activated by maybe I go again with one by searching for a line that starts with flags, so that are CPU flags that are activated, and then we search for HT, which stands for hyper-threading, and we put it just into this word border, between this word border things. Don't know how it is called, but here we are, and we see we have this flag HT for hyper-threading. So this is activated, and that's why LSCPU is showing us 8 CPUs instead of 4, because with the hyper-threading each CPU core can process or act as 2 CPUs at a time. So we are actually looking that the value of the processes in the run queue is not above 8, because we can process 8 processes at a time. So as long as we don't go above 8 processes in the run queue, we will not run into problems. Of course, then we are at the very limits of our CPU, but it's still working, and we don't have a situation of actual CPU saturation. So with CPU saturation, it doesn't mean that the system can't actually work anymore, but then we are running into scheduling problems. So now, how we can check this? We are using a tool that we've been using in the last episode, again, which would be found start. So when we run this, we have this very first column, which is procs, and there stands R, and R stands for run queue. So we have now 2 processes in the run queue, and it's far from the 8 CPUs that we have, so no problem at the time. But as in the last episode, I want to highlight this this column so we can easily watch it, and I want to run this command for a longer time. And today I also, that's why I have this terminal multiplexer tmux open, so I can switch to another bash over here, and to put a little stress on the system with the stress command, so we can see what is happening. I will show you shortly. So for now, who didn't see the last episode, we want to use the org command now, so to process the output of formstat, and I changed this command a little bit by an alias that I now put to bash rcd, which I'm loading in my bash rc in a file called org. So this is this file, and here I'm declaring, when I call org, I declare some variables R, G, and N, which escape codes or color codes. These are for red, green, and normal output that I can use to change my output through org. And I also set the output field separator of org to a tab for a nicer output. So that's not so interesting at the moment. I just wanted to show that because what I'm doing now will not work unless we have this alias and are working with this. So again, we do found start, and I call it with a 1 for so the command collects data every second. And now I pipe it to org, and I'm changing the output of the first column, which would be $1 in org, to $1, and this means I make it green so we can see it better, and then I print as null $null, which would be the whole output line each of form stat. But I want to change this again a little bit because, as I said, we are interested if the value of R goes above the number of CPUs that we have, so above 8. And if this happens, I want to highlight this with a red color. So I'm before I start this this output in the curled brackets, I do a check before. So this means when the value in the first column is bigger than 8, then do something a bit different. So I'm just doing this twice. So then this will be when it's above 8, do the first in the first curled brackets the output with a R before, so red before the first column, and else we want to see it in green, and we just see if this is working. So now here the letters progs and R, they are red, and but I see that each line seems to be no. It just are these first lines that are printed twice for some reason, but I think we can work with this. So now I change to the other terminal, and I'm putting some stress on the system with the stress command, and I do it with the option C for CPUs, and I use all my 8 CPUs. So now we see that there is a little bit of stress on the system. We are stopping this again, but we now had some situation where we would exceed the actual or saturation, or would have run into the situation of saturation of the CPU with values of 9 and 10, so above 8, and this is what we don't want to see. So then we have to look up what's happening, why this is happening, if someone's running a stress comment, or what's going on the system, if we maybe need more resources, so maybe more CPU cores, or if we have to change something to the processes that are running on the system, so that it doesn't come to these situations of CPU saturation. Of course, with farm-stat and similar programs, we could do about the same thing with a dstat command. Only that, well, it's about the same. We can try this. Only, no, that was wrong. Only that we need to call it with a special option, the P option. So here for procs, so there we have the run queue, and we see the values here in the first column. It's a little bit a more concentrated output if we want this, but it gives us the same values. And as with farm-stat, it's just a tool to monitor the system at a given time. When we are logged in and we run this program, we can see what's happening in this very time, but we cannot see what's happening over the day when we are not logged in. And for that we can use again a command we also used the last time, the SAR command, which belongs to the sysstat package that you have to install. I showed it the last time how to install and configure it. I won't be doing it today, but I want to show you how you can check for the saturation of the run queue or of the CPU. So to check for the run queue value, and with SAR we need the queue option that will give us the run queue values, and there we need the second column, so we have to change it here and here and here, well, and of course here, so every $1 needs to be a $2. And then when we call it, we go to all. So actually it seems that we do actually. Okay, it is doing with PM and AM. That's interpreting the time as a special column. So we probably just want to use the third column, although then the average that we have the last time, where we don't have the time, we don't have this value, but for the other columns, for the other lines we have the right values. So down here in the last two lines, of course, it's not 1539. Then you don't know what the value for this is for, but we will see it soon. Anyway, we have a lot of values here for the whole day, and we could run this to less and go through everything, but we could also, of course, or we might want to sort the output. So we can do this as well with org. and can pipe the output to the sort command that we just put in double quotes, and then we need to use the key option for k, so we want to sort now the third column, which will give us the average at the highest point, but it's not so important. We can live with it for now. So the third column, but then as we put the color code, which is 6 chars wide before the actual value, we have to go to the 7th char, so that's what this .7 means, and we want to have it reverse sorted and sorted by human readable values. I always think it's just good practice to use this. So we can use this, and then we just pipe the whole thing to head to just show the highest values, and we say in C at 10:15 AM we had the highest value of 5. Now you could ask, we just had higher values, we had values above 8, but ZAR is not collecting data all the time. It's so behind this is a daemon that's actually a cron job that's run every 10 minutes. So if anything happens in between this 10 minutes, we don't see as well, but at least every 10 minutes we have a value, and we can see if anything has been happening over the day. And if we really have a problem with the system, we will see high values here, because we're not looking for a situation that just happens at one time for a few seconds because I just started the stress command, but for problems, for real problems that may show that something with the configuration of the system is wrong. So we should see it here, because it should happen more often or over a longer time. But we don't see it here, so everything's fine. The highest value is 5, and we can live with it. And the saturation of the system, or there's no CPU saturation for the whole system. The last thing I want to show you today, it's already getting late again, is how we can actually have a look at the scheduling or at the CPU saturation problems on a level of the processes. And for this we don't have a real tool, but we have the proc file system, where we for each process we can find a file that's called chatstat. So if we go to the proc file system and choose any process like 27003 or something, or what do we have? 3683. There we should have a file scat.stat. So, and in this file, I have to look it up. We have 3 numbers, and the first one is the time this process was in, or the CPU time this process used, and the second is the time it was in the run queue. So we could now check through all the processes, or if we have any processes that we suspect might be the problem, we could check for them if they do have very high values here in the second value in this file. The last one would be um, the slices that run on the CPU. That's something special that is not of any concern for the moment. So actually what we could be doing when we want to check all the process, when we don't have an idea what process could be the problem, then we could run a for loop, and we use F for file in, and then we call the find command on the proc file system, and we go for a max depth of 1 because we just want to find the directories for each process, so that contain the process information. So we do type D for directory, and then we use a regex for everything that's ending with a number. So that should be all these directories with the PIDs of the different processes. And then we go on and do echo n, so we don't have no line break. And then we echo the file name. And then we we want to divide the time of the process in the run queue through the time, the CPU time it was using, because we want to see if there is much time in the run queue compared to the whole CPU time of the process. So we're doing this, it's a little bit complicated, but I hope you can follow. I do an echo and then an arc command again, which would be print, and we want the second column. Then we do the sign for divide because we want to divide it, and then we take the first column. I think you can do the whole thing in arc, but I'm not a real arc specialist, so what I'm doing is I'm running this OS command on the directory with a pid scat stat, and then we want to send all error messages to dev null, because we want to then pipe the output of this OR command to the to BC, which is a simple, or not so simple, a very complicated calculator program for the CLI. And again, we don't want any error messages. And now we are done. And as it would be a lot of output, we need to narrow it down, so we do some things. We don't want any lines that end with a 0, so we're just grabbing this out with a Y option, which means inverse, so not every line that doesn't match this regular expression should be shown. And then we go to a sort comment again and do K2 arch air to reverse the output, and go to the head comment again, and then we have to wait, and we only get colons. So this one didn't work for some reason, and it seems it doesn't even find any directories here. So what's wrong with this comment? Okay, I feel I can show. Oh, I see. In the version I'm looking for, I had a D here and I have an F now. So maybe if I change this, yes, this works. Just mixed up the variables. So we can see that we have some processes with a high time in the run queue compared to the whole CPU time, and this would be these two processes here. So we don't have a real problem as we saw before, but if we had one, we could check for the processes with the highest value here and see what's happening there. So that's already been again quite a long video again today, as long as the last one, but I hope you found it informative, and if you liked it, please subscribe, write comments, like it.